You're on physics 1 with this boss and you'd like to get a 5 and you'd like to know why the physics generator works.
So we'll explain the history so it won't be no mystery, so you better be listening. Because personally, I think this presentation is going to be lit, and I don't think y'all ready for it.
Charles von Zor, he started a chain, working with his brain he saw that electrons can change. Vito Resina were positive and negative, but no one really thought it was lit, so he didn't do it. Then Benjamin Franklin comes in and takes the lead in the middle of a rainstorm with a kite and a key. In 1749 he found the single-fluid flow, meaning that electricity is here to stay. It won't come and go.
Coulomb now, in 1784, did the math reduction of charge, so we don't have to wonder no more. Inverse square law, Coulomb got it right, practically updating its library overnight.
FV equals K, Q1, Q2, but wait, this equation's layered. All this over a simple common, R squared. So Michael Faraday came back in 1821, came up with Faraday's law of induction. He wrote about how electricity can make a motor, which led to the Van de Graaff generator. This history lesson's over.
Jabari Ford, how Van de Graaff generators work. Teach y'all a little something. Let's get it. Well, first you flip the switch and turn the generator on. Then the roller starts moving like it's going. Then the belt and roller rubs, so it starts the chain. The charge between the two is no longer the same. The roller has a negative charge. It starts rolling and moving just like a car. Because of concentration, the belt is positive, and now you got to party like positive. So the belt is moving along, it rubs against the brush smoothly like a song. But since the upper brush is negative, then the system is neutral, no more prejudice. Then you get to the big round ball. Since the ball is metal, it's neutral after all. But when you put your finger close, it's kinda bizarre. You feel a little shock from that extra charge. Hey. Yeah.
What is the law of conservation of charge? The law of conservation of charge simply states that an electric charge can neither be created nor destroyed, but simply be transferred. For example, if I run this comb through my hair, it will be negatively charged, and the only way for that to happen is for my hair to become positively charged. Therefore, they were transferred.
The word electricity comes from the Greek word electron, which means amber. The two types of electric charges are positive charge and negative charge. A positive charge contains more protons than electrons, whereas a negative charge contains less protons than electrons. It says that if you bring two objects with the same charge, they will repel away from each other. For example, if you have an object with positive charge and another object with positive charge, they will repel away from each other, just as it would if you take an object with a negative charge and another object with a negative charge. The opposite types of charge attract to each other, though. So if you take a positive charged object and a negative charged object, they will attract. The law of conservation of electric charge states that no net electric charge can be created or destroyed.
The development of the Van de Graaff generator. Van de Graaff attended the University of Alabama, achieving his bachelor's degree and master's degree in physics. After studying at the University of Alabama, Van de Graaff went to Oxford, where he met Ernest Rutherford. Ernest Rutherford believed in the idea that accelerating particles to very high speeds could disintegrate nuclei. Took this knowledge and constructed a working model of an electrostatic accelerator. In Princeton's Palmer Physics Laboratory, he worked with Nicholas Sperk, a man who helped him develop the first small but very powerful generator. As an MIT research associate, Van de Graaff developed the smallest and largest Van de Graaff generator. These designs were both ultimately proved to be more compact and capable of higher voltages, creating greater acceleration of particles. He will always be remembered. Thank you, Van de Graaff, for a machine that can mess up our hair. Yay!
Pause. What's wrong with this picture? Kathy here has an electronic device and the wire. This is not correct. She should be safer when using the Van de Graaff generator. Unpause, try again.
Oh wait, I can't use this because I have an electronic device. Now that I know better, people with heart problems, nerve disorder, and/or seizures are not recommended to use the Van de Graaff generator. Please be careful, everybody, and remember the rules.
What's wrong with this picture? Kathy here wants to use the...
You don't even know what it's.
Oh my god, I want to try it.
Pause. What's wrong with this picture? Kathy here is excited to use the Van de Graaff generator. However, she should.
Oh wait, I can't use my electronic device without doing that. And it's like my ID.